evening, everybody. It's Monday, the 20th of April, and this is Nighttime Mathematics Radio. Show always has the same format. You tweet your questions to @NightMathRadio on Twitter, and I'll try to answer them live on the air. So in this strange world where the classes have all stopped, but the homework just seems to go on and on and on, I can help you out here in the weekday evenings at 9 p.m. Pacific. So, as always, let's take a minute or two at the beginning of the show to sit back, listen to some of the strangest lyrics. There's so much lyrics, so the strangest loops that Apple's put into GarageBand, and tweet your questions on into Twitter. Again, it's @NightMathRadio on Twitter. See you in a minute or two. Welcome back, everybody. This is Nighttime Mathematics Radio. Well, it's quiet down there on Twitter, but there's been a lot of retweets of a really, really old tweet of mine. And since I thought that one was interesting at the time, I think I'll go back to it now. This is one that comes up sometimes. People ask, well, where does the quadratic formula come from? They remember it being there. They remember the result. I mean, most people, if you ask them, can manage to remember that it looks kind of like this. That if you say, well, what's the quadratic formula, they'll think for a minute and they'll say, well, it's something like, if you have a quadratic equation, ax squared plus bx plus c is equal to 0, then x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. And you can see how dedicated they were to memorizing things when they were first taking math, or whether they have to look that up or could just write it down. But where does this come from? Well, to understand where it comes from, it helps to first solve a quadratic equation by brute force, not by brute force, but by an actual one, not the generic one here. Let's write down a specific quadratic equation for a moment. And I'm making this one off the top of my head, so I apologize if it comes out beautifully. Oops, 2a. Let's try this again. 2x squared minus 5x plus 3 is equal to 0. I haven't thought this through at all. But in fact, I think this one actually is factorable, so that's okay. Let's take a look. How can we solve this thing? Well, we could factor it, but let's pretend we couldn't for a minute, or let's pretend we just don't see it. Because after all, factoring requires you to be clever. And one of the main goals of algebra is to not be clever. One of the main goals of algebra is to have the math be clever for you so you can think about more interesting things. Because after all, except for a very small numbers who get interested and study math as math itself, most of us aren't learning math to learn math. Most of us are learning math because we want to be engineers, or because we want to be physicists, or because our parents are making us, or because some reason like that. So the math itself isn't the point. What you want is some way to get to the answer, and in particular, you don't have to think about the math. Because the cleverer you have to be, the less likely it is to work when you really need it. Because you can't guarantee clever. Clever is something you get lucky when it happens. And you don't want to waste it solving a quadratic equation. Because let's face it, you've got other things to be clever about. Now, if this leading piece was 0, this would be a problem just like all the other ones you did in algebra, right? If this hadn't been a 2, if this was just minus 5x plus 3 equals 0, then you could do exactly what you've learned to do all the way through algebra. You could subtract 3 from both sides. Minus 5x is equal to minus 3. And then you could divide both sides by minus 5. X is equal to 3/5. And now we're done. You could isolate x. The problem is there's nothing you could do algebraically to do that here. You're going to, unfortunately, we're going to have to come up with something else, because there's no manipulation you're going to do here to get the x by itself on one side, because you've got three terms that are all independent, right? You have no common factors here. So what are you going to do instead? Well, let's start by dividing out that 2, because that leading 2 is going to annoy us. So I've divided both sides by 2, just to get rid of it. Now, I look at these first 2 terms and I start wishful thinking. Why am I wishful thinking? Because if I had a perfect square, I would sort of know what to do. Why do I say that? Because let's look at another problem for a second. Suppose the problem looked like this. X squared minus 5 equals 0. Well, in this case, I could just say, well, okay, I've got a perfect square out of 5, so x squared is equal to 5. And then I can take a square root. And there's a problem here, right? When you take a square, we don't know whether, since we know what x squared is, we don't know whether x was positive or negative. So there's 2 possible answers. The way you usually write that is you say x is equal to plus or minus the square root of 5. So I wish I could do something like that here. I mean, I can look at that and say, well, if I had a perfect square, it would be great. If I could just factor out a perfect square. What do perfect squares look like? Well, if you've got, say, x minus 3 quantity squared, what that looks like is x squared minus twice this thing, because you have the outer and inner terms, which are both exactly the same, which gives you 6x plus this thing squared, 9. So I could look at this thing and squint hard and say, okay, I've got an x squared, just like there. I've got a minus 5 halves, which isn't really what I want. But that's okay. That could be twice 5 quarters, right? Because if this was x minus 5 quarters quantity squared, then I would have x squared minus 5/4 x minus another 5/4 x plus 25/16. And I look at that and say, well, gosh, that's almost what I have. It's not quite right. Because here's the 5 halves x squared minus 5 halves x plus 25/16. So I look at this and say, I don't quite have that. I've got the first 2 terms, I don't have a 25/16. So I say, okay, fine, I'll add it in. Try to stop me. And now you're going to look at me and say, but you're not allowed to add a random number into an equation. The answer is right, but I am allowed to add 0. This is legit. Why is this legit? Because the thing I just added was 0. I added 25/16 minus 25/16. I didn't know what that is. And I can always add 0 because 0 is the additive identity. I can add anything. So now I can take these first three terms and say, well, great, I know what that is. That's this. That's x minus 5 quarters quantity squared. And what's left is 3 halves minus 25 sixteenths. So I got to figure out what that is. Well, 2 times 8 is 16. 3 times 8 is 24. So this is minus 25 sixteenths plus 24 sixteenths is equal to 0. So what I've got is x minus 5 quarters quantity squared minus 1/16 is equal to 0. Hey presto, I can add 1/16 to both sides. X minus 5 quarters quantity squared is equal to 1/16. I take a square root of both sides, just like I did here. And notice that this time it came out beautiful. That was amazing luck. Normally this is where horrible square roots enter your equation. There's no way to stop it. That's just where the horrible square roots go. X minus 5 quarters is equal to 1/4, plus or minus. Square root of both sides. So x is equal to 5 plus or minus 1 over 4. And there's my answer. So my answer is x equals 6 quarters, or 3 halves, or x equals 1. And those are both answers to this equation. Now, I could do that same procedure over and over again every time I had a quadratic equation. It would be horrible, but it would work. But I don't want to. What I want to do when I'm doing math is do hard work exactly once and then never again. So how do I do that? Let's take a look. You can tell I've been running that math radio for a little too long when it's hard to find a page that's blank. Suppose instead I started with ax squared plus bx plus c. And honestly, I did last time. I just started with a specific a specific b, and a specific c. But this is every quadratic equation. This isn't a specific quadratic equation. This is all of them. But the cool thing is I could do exactly what I just did. I'm going to assume also that a is not equal to 0. Because after all, if a is equal to 0, this is a problem from the very, very beginning of algebra, and I don't need to do any hard work. So let's divide both sides by a. Remember last time I divided both sides by 2. I'm doing exactly the same thing, just with my generic letters. X squared plus b over a x plus c over a is equal to 0. Now last time I thought, gosh, if this was only twice something, and what would it be twice? It would be twice b over 2a after all, because after all, b over 2a plus b over 2a is equal to b over a. So if only I had x squared plus b over a x plus b over 2a quantity squared, right? The thing that would be the third piece of a perfect square, then I'd be good. But of course I don't have that. That's cheating, but it wouldn't be cheating if I subtracted it off 0. So that's what I'm doing again. Exactly what I did last time. I've added 0. Adding 0 is always legit. I can look at those first 3 terms and say that's just x plus b over 2a quantity squared. And now I've got this bit of a mess here. Let's clean up this bit here. I've got let's square it out. Remember, you can always square fractions. You square the numerator and square the denominator. Minus b squared over 4a squared plus, well, here I've got c over a, but obviously I'm going to want to have a common denominator. My denominator is 4c squared. Oops, sorry, 4a squared. What am I doing? So I need 2a in numerator and denominator, so that's 2ac over, let's see, it's going to be 2ac? No, it's going to need a 4. It's going to be 4, multiply this by 4a, I get 4a squared, multiply this by 4a, I get 4ac over 4a squared is equal to 0. Let's move those pieces to the other side of the equation, just like before. So I have x plus b over 2a quantity squared is equal to b squared over 4a squared. And since they have a common denominator, might as well just write them all in the numerator. B squared, and this becomes negative, minus 4ac over 4a squared. Take a square root of both sides. X plus b over 2a is equal to plus or minus the square root of the numerator here, b squared minus 4ac over 2a. Taking square root of both sides. Now I subtract b over 2a from both sides. I get x is equal to, we already have a common denominator here, so that's easy. Minus b plus or minus the square root of b squared minus 4ac over 2a. That's where it comes from. The reason you spend all that time learning how to complete the square, or at least one reason you spend all that time learning to complete the square, is because that lets you understand why the quadratic formula works. It's just the answer you will always get when you complete the square in a quadratic equation. And the question is, well, then why did we spend all the time learning to complete the square if it's only got that one use? And the answer is because it has a lot of uses. That's one of its uses. Come calculus, you'll see many, many, many more. This is Nighttime Mathematics Radio. I'll take a quick look at Twitter. This is nothing new here. So it may be time to end the show. That's okay. Keep tweeting your questions to @NightMathRadio. I'll try to answer them live on the air. And for the moment, in this weird world where the homework goes on and on and on, but the classes have all stopped, keep on tweeting it in. Keep doing the math. Stay safe, everybody. Good night.